Okay, so let's talk about hanging a picture. So we've got a picture here, and let's say the weight of the picture or painting or something like that is going to be 20 pounds. All right, and you want to hang it on the wall. And so you have on the side of here a couple little eye hooks, and you have a nail up here, and you run a wire over here 60 degrees like that. Okay, and I want to know what's the tension in the wire. So clearly, two each the tension's pulling here and here. Okay, mg's pulling down like that. So we got 60 degrees and 60 degrees. Okay, so 2 times t sine 60 degrees is going to equal mg. So t is going to be equal to mg divided by 2 sine 60 degrees. So there'll be 20 pounds divided by 2 sine 60 degrees. So the tension comes out to be equal to 11.5 pounds. Okay, well, you're also squeezing the picture frame. So I want to know what's the squeezing force. So what is the force of squeezing? Well, you look and it's going to be this force plus that force. So that's going to be 2t cosine 60 degrees. So we just plug in 2 times 11.5 pound cosine 60 degrees, and we find out that's also 11.5 pounds. Okay, so the tension's 11.5 pounds, the squeezing force is 11.5 pounds. But then you look at that and you say, well, that's kind of ugly right there. Okay, you got the wire hanging up above the picture. So you decide to retie this so that the wire comes up just to the top of the picture. Well, if you do that, you discover that that's going to be a 25-degree angle, for example. And so now I want to know what's the tension. Well, turns out the same thing. We got 2t sine 25 degrees equals mg. So t equals mg over 2 sine 25 degrees, and mg is still 20 pounds. And so this now comes out to be a tension of 23.7 pounds. Notice the tension is now actually more than the weight. Okay, what about the squeezing force? So the squeezing force is 2t cosine 25 degrees. Plug in the numbers and you find out the squeezing force is now a hefty 42.9 pounds. Okay. In fact, sometimes if you buy an inexpensive or piece of art or something, and you're not real careful with it, you can actually break the picture frame because the squeezing force can now exceed the strength of the picture frame right there. Okay. Well, what happens if you keep going? What happens if you tie this really tight right here so that that's only a 5-degree angle on each side? Well, now 2t sine 5 degrees is going to equal mg. So t is going to be mg over 2 sine 5 degrees. If mg is still 20 pounds, then the tension is now 115 pounds. Okay. Now that actually might be enough to actually pull the wire completely out of that eye bolt, or pull the eye bolt out of the wood of the picture frame. Okay. If it doesn't, then you're going to have this huge squeezing force right here. So now the squeezing force is going to be 2t cosine 5 degrees. And so that would be 229 pounds. Okay. And so that's that. Here you have a problem, that you can't actually do that. Now, actually, somebody a while back gave me kind of an inexpensive picture frame. Well, you can't hang it. You have to hang each one separate here. You can't hang it with a wire. And I said, yeah, I can. And no, you can't. And so what I did was I put 2 nails in the wall right there and had a wire that did that. So each of these angles was actually pretty steep. And guess what? Mathematically, that was the same as that. Okay, so it worked.